All right. Happy Tuesday. We are plugging along. So, you doing the readings at all? Is that helpful to go through? Okay, cool. So, again, we're going pretty quick through a lot of those basics because these are things you've done before. We're just looking at the Python syntax essentially. So I do want to spend a good amount of time on files because there's a lot of really cool things we can do with files and some cool built-in stuff working with specifically CSV files and things. So if we want to pull in data and grab it, CSV is a very common format. That's our comma-separated values. And this way we don't have to reinvent the wheel. Doing this by hand is really obnoxious. So we'll spend some time storing data as files, reading data from files. We'll be doing that with the next project. This first one, our little tax calculator, just a chance to exercise some Python. Not a whole lot of anything interesting, honestly. It's just an exercise here to go through and get that. So that one will be due, right, that's next week, will be due on Thursday, right? The 30th. Yeah, so that's next Thursday. Okay, cool. So we got a little bit of time on that. If you haven't started it yet, it shouldn't take super long. Just a chance to try some of this syntax and format and things. Get your feet wet with Python, more than just a little hello world. So next time we'll be doing more interesting stuff with files here. You go pull up his page here. So you may or may not have spent a little bit of time looking at this idea of what happens when computers actually do things, right? That, conceptually it's fun and important and interesting and all, but know that the CPU is really fast, right? Memory is really fast. Things that are slow are input and output and other external devices. So when we talk about files, that's way slower to read and write from disk than it is to do something that you already have, do something with something you already have in memory, right? Once you've loaded it in memory, you can manipulate it, deal with it super fast. Reading and writing from files is slow, comparatively. So that is a slow point in our applications, trying to load things from files and things. If you've got a solid state drive, it's going to be a little faster for you. The older traditional hard drives are much slower, those sorts of things. Anytime you have to pull data off a network, it takes a long time. Right? So like anything outside of that, it's already in memory and I'm dealing with the CPU, is going to be slow. So just know that part gets to be a bottleneck. And even like printing to your console is extremely slow compared to how fast you can do computations, right? We can compute really big numbers really fast, but if I have to spit out every step of the way, it's going to be really slow. Do we look at that? No? Okay, let me fire a PyCharm here. This is what, week 3? Is that what we're in? I can't count anymore. 1, 2, 3? Yeah, week 3. Okay, good. So let me start up a new project. Again, just put it in your folder. I don't know why this new version of PyCharm here doesn't have this name box. Boggles my mind here, but sure, it's not my software. So just put a slash and add your folder name here. And it'll make that folder here for you, right? So that way you'll put your project in the folder. We'll make life easy. So this is week 3 files. Go ahead and create that. All right, get rid of the garbage starter script. All right, so if we wanted to look at things being slow when we print to the console, right? It's really quick and easy for the computer to do some quick calculations. So if I have, I don't know, number 0, and we say while number is less than, let's go. Remember, you can use this cool digit separator, which is, I love this in Python. Just be careful not to like put it everywhere because then you're gonna just be obnoxious, right? You can put it anywhere, Python just ignores it, right? So while we're less than a billion, we'll take number plus 1, then we're done, we'll print number. Right, so how fast can we add 1 up to a billion, right? It's taking a second. A little slow to do a billion operations. I guess I should have done like 100 million or something. Well, now we're invested, right? Now we want to see how long. All right, I kind of want to give up now. Can we pause it and see? I didn't run it in debug mode to even pause. Wow. There it goes. All right, that was a billion. What was that, like 15 seconds? It felt really long, right? But if we're printing every step of the way, it's going to be much, 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 much slower. Right? We didn't even get to a million yet. There's a million. Because these output operations are really slow in comparison to how fast we can do something with numbers in memory and our CPU. Right? We're at 4 million now. Right? This is going to go crazy slow because it has to print every single one of these. It's going to be a little slow. Right? We're not even working with the disk yet. This is just console output here. So if we start trying to read and write stuff from disk, it's going to be even slower. So we can, and Python makes this really easy for us here. And I always just go copy paste the syntax because I can never remember here. We just say, yeah, open. So you open and you give it the name of a file, which is really nice and easy. So we can say, hey, I want to, and this is using this really cool, oh, he doesn't have that shortcut yet. We'll get there in a minute. So we can just say, some file is open. And then in quotes, you give it the name of the file. So, I don't know, here's number.txt. Or file name extensions are just helpers. They just help your operating system know what kind of file it is. They're not required, but it just makes life easier. So a .txt file is just a text file. It just has text in it here. And by default, when we open files, we're opening it for text-based reading and writing. We can open them as binary files later. That's more complex. We're probably not even going to get into it here because really that's more trouble than we want to get into here. So text files work out really well for us here. So we'll open number.txt, and then instead of printing number, we'll say I want, some file, where did it go here? No? Oh goodness, where's his line here? I just want to cheat. It's reading the file, printing to the file. Where's my, goodness. Writing the file, there we go. Oh, I'm sorry. I didn't jump down far enough here. We have to tell it, so this is for reading the file here. If you want to write the file, you have to tell it, hey, we want to write to the file. You give it a W for write. So the default is open for reading, at W for writing here. Now I can actually go print to my file here. So now it's my sum file dot write, and I want to write the number. Let's see, probably as a string, right? As a string. And then we probably also want to add, or maybe we do this as a formatted string. This will work even easier for us here. So I can do a formatted string of the number, and then a new line character, because we like when our files go down a line. So we don't even need to print the number here. We'll just write it to the file. And maybe we'll do like, maybe a million. I think this is going to be real slow here. We can try it and see. So when you're working with files, you need to open the file, right? For reading or writing, you need to read or write the file, and then we need to close the file. If we don't close the file, it's going to hang on to it. When Python shuts down, it'll let go eventually, right? Because our Python program will stop. But it's bad habit to just let Python's closing actually close off the file here. So you want some file dot close. Oops, there we go, close, to say we're done here. Right, so you open it, you read or write from it, and then you close it. So now we should want to print number. When I run it, if the file doesn't exist, it goes and creates it for me. So we'll see it in a minute here. I can go, so I say, where is it here? Show in Explorer, open in the Explorer. We'll see now I have a numbers.txt file in my project folder, because that's where this one was running from. So the local path, if I don't give it a full path here, and don't say, hey, it's C:/ my file directory / here's the name of the file, it's going to put it next to your script. Right? It must be relative here. So it's just wherever it happens to be here. Oh, here we go. Project settings be added to Git. No, we already did that. That's fine. And now it shows my number.txt file. So eventually it shows up on the left. It's not the super fastest thing, and it's still running here, but I can open it. Should be able to open it. Thinking about it. File's too large. 368.8 megabytes. Oh goodness. Oh, I took off the wrong line here. We're writing zeros over and over and over. We've got an infinite loop. So how far do we write our file? 473 meg. It's not too bad of writing zeros. It's a lot of lines of zeros. I screwed that one up. That's all right. We'll take number plus 1 again. Now let's try it again.
Did you create that text file or did it by itself?
Python will do it by itself. Yep. And it actually finished pretty quick here. Now, that wasn't too bad, but that was just 1 million. But now if we look at our file, it's only 700 meg. So when you open a file for writing, if it exists, Python's going to blow it away. Right? It truncated what was there before and replaced it with this content. So you got to be a little bit careful what you open here, because this will erase the previous contents. That should probably go down another line, right? Previous contents. All right. So just be careful here. But yeah, we got 1 million. It wasn't too slow for that one, right? And now we can see I've got 1 million lines. Yeah, Notepad could open that. 6,888,890 characters. That sounds like a fun math problem. How many actual individual characters are there from the numbers 1 to 1 million? All right. Cool. Yeah.
It didn't even print 1 million.
Because we stopped when we got to equals 1 million, the loop didn't run anymore. So we got to 9999999. Yeah.
Whatever it is that you're trying to like write something else with the set file, you have to title it, the name of it, .write. Like that's like the keyword.
So yeah, write says go and put this information into the file. Yeah, so using this object that we created with open here, it's going to go and do this. So this is the built-in file opener. Look at all the fun things we can give it. That's a ton of different options here. It's lots of fun. Yeah.
So it creates it by default. You don't have to say, like, if the file doesn't exist,
Nope.
like, you have to do it in C++.
Nope. It'll just create it. If it doesn't exist, it makes it. If it does exist, it blows it away. So it's a little bit dangerous. You got to be a little careful. Like maybe you want to see if the file exists first. Yeah.
What's the point of files?
So we can store information, right? So most of the time, people are going to be having information come from elsewhere. It's actually really boring and tedious to like have to type everything in every single time. Some programs, sure, you'll hit run, you'll type in your stuff, and you'll go. But most of the time, we want to work with information that's already stored somewhere. You know, files is one option. Eventually, we'll get to how we can get information from web services and things, and that's much more interesting. Yeah.
Is there a way to add to the file, not just?
Yeah, yep. So with all these crazy options you can give it. So we gave it W for writing. You can give it other things here. So I think it is W and A for append. Let me see. Append. Is that really the only option here?
I think you only talked about like W, and that's funny.
I think it's, is it plus? You know, I can never remember. I don't know, Python, write file, append mode. Let's Google it. I don't need the AI to give me an answer. Like the first Stack Overflow one's going to work here, right? Oh, just A for append. Just A, not W. So W for writing. This is A for append. Right, so appending will leave the content alone, and you'll just keep adding to it, which is nice. So this one we run now, we'll get another 1 million in our file. Oh goodness, it only shows us 2.56 meg. I guess we can't see to the end here. But eventually, it's big. Well, probably, I think it'll do it in Notepad. Let's try that here. Yeah, 15 meg, maybe. Do we see a reset somewhere in the middle here? And then it resets. Yep. So it looks like it's successfully appended to it. Right? And every time we run, we can add another 7 meg of characters if we want here. Right? In append mode. That's an option. Yeah.
Does append work if the file doesn't exist yet?
Oh, let's try it. I think it should. Let's try it. Yeah, numbers 2. It opened it up and it appended to nothing. Yep. All right, so we can write files. It's only so interesting to write them. It's much more interesting to read files, right? Because storing information is good, but if you can't get it back, it's kind of worthless here. This for. I don't know if this is still a thing. Yeah, this is a thing a former coworker of mine created here. So S3 is Amazon's AWS's storage solution. This is S4. It is write only. So you can write to it, There's no reading. It's just a joke. It was kind of funny. And he actually had people like inquire about it here, which was entertaining. Like, hey, how can we buy? Okay. But yeah, if you can't read it, it's pointless, right? Because you need to be able to read the information we wrote. So looking at reading files then, it's much more fun. So let's do, let's see. So we're going to do that same kind of process. So it's open, but without any arguments. It's going to be for read mode here. This is some file to read. It's open, and let's do numbers.txt. Let's make another one here. Let's actually go make our own file here. Let's go make a test file. We'll add in here, I don't know, 5, 10, 20, 30, 50. Maybe we'll stop there. So we'll read test.txt. So we can make our own text file. We got some contents here. Now, there's a couple options when you want to read the values back out, but eventually we want to close it here, right? So I'm going to add the close in so I don't forget, because I forget that all the time. So with my sum file to read, I can read everything into a single text object, a single string, or I can read line, which will read one line at a time and wait to see if there's more to read, if there's more to read, if there's more to read here. Or I can read lines, which will read all of it into a list of strings, which each string being one line at a time. So a couple different options depending on how you want to go about it here. If your file's really large, right, reading a single line at a time is going to be efficient because it's going to kind of keep that file open where it was, read the line, and then what you've pulled into memory is just that line. Right? Imagine if we had like Moby Dick as a text file. Reading all of it in would probably be a little bit large. I can imagine it's got a lot of words in that book here. Maybe we don't want to do that, right? For my computer, most of our computers, you could probably hold that no problem, right? It's not gigabytes and gigabytes of memory. But for really large files, if we're working on crunching millions and millions and millions and billions of data points, you don't have room to read all that in. So you've got to handle little bits at a time, depending on what we're reading. So we got some options. So read line is pretty handy doing it this way. So read line will give us the line, and then this is going to give us, I don't know. So here's the line. It's this, and then we can say while line. Now, this is taking advantage of Python being truthy. Remember, everything eventually is true or false. So as long as we're reading something here, line is true. Right? We should be able to keep reading. Let's see. So while line, let's print. Well, let's print the line. Nothing super interesting. We should be able to read the file, and we're done. We'll go close it here. So let's. That's adding a bunch of numbers every time is getting a little annoying here. We'll do like 1,000. That should be kind of quick. Uh-oh. We stopped. I didn't read the next line again. I keep doing these infinite loops here. It's all right. So print the line, and then go get the next line. There it goes. Notice we get like some extra new lines here. Right? When it reads the lines technically end with a new line character. That's how your text editor knows to go down a line. And when we print adds a new line here. So really we don't want to add that new line character. So let's say, hey, just don't end with the new line character, end with nothing. Right? Just take whatever that line was, because most of them already have the new line character in there, and give me that. Your output will look a little bit nicer. Let's see, we got 50,000. Where did we get? Oh, printed the number. Oh, that's 1,000. Now this last one though, because 50 didn't have a new line character at the very end, we didn't get a new line character, so the 50 got smushed in. So maybe at the end of all of that, then maybe we want to print just to get a new line in here. And we probably don't even need to print the number. I'll leave that one commented out for now. But no, sure, we read our file. We got some data out. Now this is one line at a time, right? Now if we want to do something with it, right, we can do some conversions, we can add this up, maybe we pretend this is a lotto ticket, whatever it happens to be, here we can do all that. Now, reading and writing kind of go hand in hand, right? Because I need to know, okay, here's the first line, here's what the second line is, here's what the third line is, here's what the fourth line is here. So to do anything sort of interesting, like, hey, I want to have a grade book, and I want to have names and grades, right? I'm going to need to know how that's written so I know how to go write it, or how to go read it. Or if I know how I want to read it, I can write it in that format. So we can kind of go either direction depending on how we want to do that here. So let's go say we wanted to have a gradebook, right? And we'll assume it's probably empty to start here. So we can make a gradebook file, or we can go open one here, or we can even check to see if it exists here. Where is that? It's exist. Make sure the file exists. Let's see. Does he have a check in here? Oh, if you're trying to read it, it'll crash here with exists because it doesn't exist. So we can add try and accept. Do we do try and accept blocks yet? He jumps ahead with some of the chapters here. It's the try and catch, like you did in C++. It's try and accept because it's catching an exception here. So we can try those when we read files. Let's see. Does he have a quick example? I just want to copy paste it here. There, using the try and accept. Right, so, hey, let's try doing this thing and tell them, hey, we can't open it or not. Right? So we can try something, the open may or may not crash, and then if it crashes here, we'll go do something and quit our program or tell them whatever here. So why don't we ask them, hey, what's the name of your gradebook? Because maybe you want to keep one gradebook per class. Right? We can do that. So we'll have the class name is an input to the name of your class, and then we're going to try and open the file. Right? See if the file exists. So we can try open class name. And now, most people don't add the .txt in, so if I ask for the name of your class, I'm going to add a .txt to it so that I know it's a text file, so I can save all that gradebook information here. So we'll try and open it here. So this will be the gradebook. It's open for that. And if it crashes here, we're going to print. Actually, do we want to print something, or do we just want to make the file? Like make an empty one? We don't really need to like end the program. We can just go make the file, I guess, so that it's empty. We can go do that. So we'll say gradebook is open, and we'll open it for writing. I'll go make the file for us here. And I can close it out because there's nothing in here to start. It's going to be empty here. But if it opened, great. If it didn't open, sure, that's fine. Now it's warning me here. That's just a warning, not an error. That we're catching everything here. Right? We said just any sort of exception, which is probably fine here. You can get specific around what types. We haven't really talked about exceptions yet, so don't worry too much about that. So now we've got the file. Right? We either opened the file, or we opened it for writing and then we closed it. Sure, that's fine. So there was nothing to read here. So maybe our data then is just an empty dictionary. And in this case, oh, I'm sorry, if it did open, we need to go and read it here. In this case, we'll just say our data is an empty dictionary here. So how do we want to read our gradebook? We can start with reading. Maybe we have a name and then your grade. Is that very exciting? Maybe we can add in other assignments later or something. Maybe we just do a total score. So if you have a name and then a score, we could do that on one line. We could do it on 2 lines. We've got some options. So I think maybe every 2 lines, we'd have a name and a score, a name and a score, and a name and a score, a name and a score. That's pretty basic. It would probably work out. So we can go and read essentially 2 lines in. One's the name, one's the score, one's the name, one's the score, one's the name, one's the score, until we're empty. Right? So we might have, our line is gradebook.readLine, and then while line, we're going to take our data. Maybe, I don't know, so next line, then we'll go and call read line again. So line will really be like their name. I guess it's probably better to call name here. So while name, and then this will be the score, is the next line, and that's probably a float, right? Do you guys like your percentages? Or like, 92.7, and you're like, oh, can you please round that? Because it's almost an A, and you're like, sure, why not? Because rounding is easy. I'll just pretend it didn't have that, and it'll round for me. All right, so we got a name and a score, and we'll take our data, our gradebook, essentially, add the key of name. Oh, we haven't done dictionaries yet, have we? Shoot. We're a little out of order here. We did lists, right? We can just do lists are annoying. We can do lists, that's fine. So we'll have, instead of a dictionary here, we'll have names is a list, and we'll have scores as a list. This is terrible here, but that's okay. We haven't figured out a better way. So we'll take names, and we'll append the name, and we'll take scores, and we'll append the score. So the first name will match with the first score. The second name will match with the second score. The third name will match with the third score. Like these like side-by-side lists. Right? Just think of it as like vectors here. And then we need to go get the next name here and read it out. Okay, so we'll have names and scores. So this one, if it was empty, we'll have names and scores. So we either read all the information out or created the file and have an empty names and scores list. Right? And then we have some sort of menu, right? So I don't know, while their choice starts as this and while choice does not equal, I don't know, quit or something, sure, why not? As long as you didn't tell me to quit, let's go ask them to do something. Right? So we'll get their choice then is equal to an input of, trying to throw a menu into a single input is a little bit ugly. You can, but you'd have to add your own new lines. Maybe we just print. Right, 1 to add student, I don't know, 2, look up student, and then print, I don't know, 3, display entire gradebook. Look up, or is this like add score, edit score? I don't know, how about edit student? So you can add, you can edit, you can display the entire gradebook. I guess maybe quit, then it will be 4. Grid 4, save and quit. Excuse me. We could save every time. We could save once. Most people don't Control-C exit their programs, so it's probably safe to have that as an option. If you wanted to save after every edit, you could too. Okay, all right, so we got a little choice menu here, and then we can check. All right, so if the choice, oh, now we need to actually get their input, don't we? I love my infinite loops here. Choice is just an input. Okay, we don't need any prompts because we already did the prompt here. So then if my choice is equal to 1, right, the character 1 here, because we didn't convert anything to integers, right, just the character 1, we'll go add a student. So we need their name. So name is an input of enter the student name. And then score is a float of an input. Enter student's score. And we'll take names, we'll append the name. We'll take scores, we'll append the score. Good. All right, so adding's pretty easy. Elif, my choice is 2. We'll come back to this one here. That one's probably a little bit harder. Choice is 3. We just want to print them all, right? So for index in range, the length of my names, right, that'll give me 0, 1, 2, 3. When we range, we don't get that last value. So if I have 10 students, I'll get 0 through 9 with my range. Works out really nice. We're going to print, we'll probably have a formatted string here. So we want to print names, index of that index value. So 0 and 1 and 2 and 3, right? So that's their name, and then their score should be scores, index of the index, right? The 0th index of each match, the first index of each match, the second index of each match, and on and on and on. So we'll go print them all out. And then else, maybe elif choice is 4. That was for save and quit. Here, we need to go write the file. Right, so we're going to go write these things in pairs. I think we said we were going to do. So we're going to say, I want to, here's my, so the gradebook was going to be the name of the class, right? We got to open this up again here. Take both. And actually, there's a little shortcut. Does he have that one in here? Does he have the width? I don't think he does. No. No. Okay, so there's a little shorthand here because I always forget to close it here. You can save this here, which is kind of nice. So we're going to say, I think it's with gradebook is open. Is that it? Gradebook as. What is the shortcut? Python open files with keyword. I can't spell. That's all right. Keyword. No, I don't need. Just give me the first link here. With open as. Okay, I was backwards here. It's always a little bit backwards here. So with open as gradebook. So essentially saying anything that is inside of this block happens while this file is open here. This will auto close when we're done. It just saves you from having to remember to close it. Really just one shortcut here so you don't have to remember your close line. I think it's nice and easy. So I've got all the gradebook information, so I can open that file and I want to overwrite it. I don't want to append to it because I've already read everything in and I already have the entire list here. Right? We don't want to deal with appending. Trying to edit lines in the middle gets to be really awkward. There's ways to do it. It's probably more trouble than it's worth. For these small little gradebook files, we can just rewrite the whole thing. It'll be okay. We don't need to worry about trying to edit in the middle. So we're going to open it, and then now we're going to loop through both lists again here. So for index and range here, we're going to, not instead of print now, I'm going to take my gradebook, and I'm going to write the name and a new line character. And then I'm going to write the score and a new line character. Ending parenthesis. There we go. All right, so we're going to do them in pairs. So name on one line, score on another line. Name on one line, score on another line. Name on one line, score on another line. As far as we go here. Right. All right. The last one we wanted to do was this edit here. We'll just print. Can't do that yet. Oops. So if we want to use apostrophe in there, I can do full quotes here. Otherwise, I have to escape my apostrophes out, right? You can use that backslash to escape it. But if you only have one, you can just use the opposite for your enclosing ones, which is nice. So we'll come back to that one because we have to go look up the student and then match the same score on it here. Let's just see if we can get it to work. All right, enter the name of our class. So let's have CIS 298. So it should have gone and made a file, right, because it didn't exist. So let's go add a student here. So let's add Eric, and I probably have 100 here. And then display the entire gradebook. We get Eric with 100. Nice, let's add another student. We'll add my son Jeb. He is not doing it as well as I want him to do, but that's okay. He's only 17. He's got like another year, right, till he has to get better at this sort of thing. Right, and then if we display the entire gradebook, we get Eric and Jeb. Awesome. And then we want to save and quit. And we see CIS 298 TXT. We get a couple lines here. Eric has 100, Jeb has 90. Right, we got that last new line character, so we got this ending line here. So let's see if we can go and load it now. Right, so we go and run here. The first time, name of our class, we do CIS 298. It should go and read the file here. So if I display the entire gradebook, I get Eric and Jeb. Oh, I get extra new lines. Oh. Right. Eric had a new line here because there was a new line at the end of that. When I went and read that information here, this one here, right? We just appended the name in. It had the new line characters. If we don't want the new line character in here, we can use, is it trim? Strip. So strip will strip out the extra white space. Right? Returns a copy of the string with leading and trailing white space removed. Right? So let's get rid of that extra space here. When we read the gradebook as a float, it already did the trimming for us. Notice we didn't have the extra new lines on scores because that was a floating point value. We read it as a numeric value. Converting to float says, oh, if you've got an extra like space over here, just forget it, ignore it, right? So it took care of that for us. So that one was nice here. All right, so we got that one. And then maybe because we have these numbers as floats, right, we could also do some other interesting stuff here. Maybe then we could print the average. I don't know, print. Average score is, well, that's the sum of my scores divided by the length of scores. Right? So sum is a nice built-in function. If you have a list of values, you just hand it the list, it'll sum it for you. You don't even need to do your own loop here. So because we've got them as floating point numbers, we should be able to get a sum here. And then we're properly trimming off that extra new line. Let's try that again. So CIS 298. Let's display the entire gradebook. And we get the average score 95. I think that's calculating correctly. So we can go add another student. We'll add Vivi in here. She does not want to learn how to program. That's okay. Not everybody has to. So she probably only has a 70 in the class. We'll display the whole gradebook. And our average went down. We got 3. So we'll save and quit. And again, we overwrote the whole contents because we already had it all in memory here. And then we get Eric, Jeb, and Vivi. Okay. We're doing okay so far? Cool. So we can read and write, and the format goes hand in hand. However we want to write it, we need to read it. Is that a question?
Could you upload the program to your children's class or they class?
Yeah, they should all be out here in the course repository. It's not?
It's only on the default.
Did I forget to commit and push? Let me see. 290. Probably just forgot to push. 298. Oh no, that's only has week. Yeah, I committed and didn't hit the push button. So sorry, I had them committed. Now that'll put out week 2. Let's see. Yeah, there it is. Okay, sorry about that. All right, yeah, we'll do week 3 when we're done with this one. Thank you. Yeah. Is that a question?
I was just trying to see what you were doing on form.
Sorry, where?
I was just trying to see what you were doing for if choices follow choices forward.
Oh yeah, so we're just printing, right? Just save the file, and then that will end our loop because our loop was running as long as it wasn't a 4 here. Yep. All right, then the last one we had to do was figure out how we edit a student. So we need to go find the name, right, in the names list, and then we need to go get that index and edit the score at that index in the scores list here, right? So we got a couple options. We can loop through. So, all right, so we need to find out what's the name. So name is an input of enter the student to edit. And I need to go find their name, right? So names, now I've got a dot index here. Index will return the first index of a given value. That's perfect, that's the one we want here. And then this one says it raises a value error. Oops, can I hover? I can't hover over that. There, if it's not present. So it might crash, you give me a name that's not in the gradebook. So we probably need this in a try and except block here. We'll try it. So this will be the index then. Is the names at the index. So we're going to try and accept. And then we'll just print, I don't know, student not found. Please try again. I don't even want to put it in a loop. I'll just let them go back to the choice menu here. I don't really care too much here. But if it worked, great. So then maybe we'll say print, I don't know, current score is going to be, I'll do that as a formatted string, scores at the index, right? Because if your name was found in index 4, your score is going to be at index 4. Now, this only works if you don't have duplicate names. So it would not have worked for me all through school because there were always 3 Erics in every one of my classes because I was a popular name back then. So maybe you have full names. I don't know. We don't have to worry too much about that. You can solve those sort of hard problems later. It's okay. So the current score, and then we'll get a new score is a float of an input. Enter the new score. And then we'll take scores at the index and assign it the value of the new score. Right? Just go change the value. Right? Cool. So we should be able to go edit. So CIS 298. Let's go edit a student. Let's edit Jeb. Right? Current score is 90. His new score will say, hey, maybe he actually turned in that homework he forgot about here. So we'll put it to 95, display the whole grade book. And he's got a 95 now. Right? And when we save and quit, the new file contents are written out. We got it all here. Right? So that works out kind of nice. Now, this works because we know, hey, here's one line, here's the next line. Here's one line, here's the next line. And we can just read until we run out of stuff to read. Right? Now, if we were trying to do something slightly more interesting, like, hey, give me a list of assignments here and all your scores to the list of assignments, and then I can go compute your final score, that gets to be a little trickier. Right? Because I might not know how many you have here. So we need to put some information in somewhere to tell me how much I should go read. It's one option here. So if you want to change all this up, or maybe we'll do this as version 2 here. So I don't want to, I'll leave the easy version here, I guess, and then we'll go, let's go add another one here. So let's do a new Python file. Let's do gradebook. So this is gradebook v2, right? We'll take this one here, but we're going to go modify it, right? Here. So what we want to do here now is instead of having their total score, we want to have the list of assignments, right? How do they do on each assignment? Okay, so still have the name of the class, still have the file for that, but now our format's going to be a little different because I don't know how many assignments they're going to have. So we need a place to tell our program how many assignments they had. So maybe we want to change the format of our file. So maybe we have name, and then here's your number of assignments. And I can go read that out and then know, oh, hey, I need to go read the next number of lines here because you've got that many assignments here, right? So we go open it up here. Now the scores list is not going to work very well, right? Because I don't just have a single list of scores, right? So each person is going to have their own list of assignments. So it's starting to get a little messy here. Let's see, can we do, what can we do instead? We'll have name, because we haven't done dictionaries yet. So the dictionary would help with this, but we don't have that yet. So what can we do instead? We could have another list. There we go. So let's make scores a two-dimensional list, right? A list of lists. You've done those? So each item in there will be another list of values. How about that? We do it that way? All right. So we'll go read the line for the name, and then we'll have the number of assignments here. So this will be our number of assignments. Assignments is going to be an int of my gradebook.readLine. Go read line, this will tell me how many assignments I have. Then I need to go get that list of assignments. Right? So hey, you've got 7 assignments here, so I'm going to go read 7 more lines to get their score out. Here. Yeah?
How does it know, like, just by the reading line, like, is there, like, from the spaces, or?
So it's just going to read the next line. So we'll have a name. So the first line we read is the name, and then the next line is the number of lines it has to read next. There's one way for us to go store that information, right? So then I can go through and get that many more lines here, right? So then for assignment in range number of assignments, we know that I can go read a bunch more of these lines here. Right, so we need to make a list of, this is, I don't know, my scores. Oh, shoot, this is assignment scores maybe. Scores equals a list. And then for every assignment in that range number of assignments, we can go read that value back out here. We'll just call it assignment score is my gradebook, read line, and again, that's probably a float, not a flat, float. Gradebook, read line. And then we'll take our assignment scores and we're going to append that one to it, the score to it. So if I had 7 assignments, I should be able to go read 7 values out, adding it to my assignment scores list. Once I've gotten all of those done, then I can go append the name to the names list and my list of scores to the scores list. Right? So we'll take names, append the name. We'll take scores, we'll append the assignment scores here. Right? So we'll go add all those in here. So we can read those out. Again, we don't have anything yet. It's empty so far, but that's okay. So we've got then the name of our class. We've got names and scores is empty. Add student, edit student, display the gradebook. Now we need a way to like add an assignment, right? So adding a student is just empty, right? So 4 isn't going to be save and quit anymore. Maybe that'll be 5 is save and quit. Maybe 4 will be then add assignment. Print 4 add assignment. Display the gradebook, edit a student, add the assignment. Now, we don't really have the assignment name, which is a little bit unfortunate, but again, that's okay. We can make it better later, right? We're just kind of working on it a little bit at a time here. So when we add a student, I don't know what assignments we should have yet, right? Maybe I know that somewhere. I don't think we really have a good sense of how many assignments we should add for them. We can edit the student. Maybe then we'll go through and say for every assignment we can add a score. Maybe. You can display the whole gradebook and add an assignment. So at some point we need to know how many assignments we have. So it might be nice to keep track of that in here somewhere. So let's see. So maybe we'll say after I've read all that out, we've got assignment score, we've got the class name. We should have like the number. I think we should have the number of assignments. Number of assignments starts at 0. And then if we went and read some assignments here, we can say, hey, the number of assignments is the length of the assignment scores. Hey, there were 7 assignments. There were 5 assignments. There were 2 assignments, whatever that happened to be here. So every time we go add an assignment, then we can go add one to that number. Might make life a little bit easier for us. So adding a student gets us the name. Now we don't have a score, right? We're going to have assignment scores, right? So for every assignment, so for assignment in the range, number of assignments, we'll say, I don't know, the score is a float of an input of the score for assignment number. You know, it's not the prettiest thing here to do it by number, but that's okay. We can come back and fix it later. We'll do a little bit at a time. And it's a little long on that line, sorry, but if it wasn't zoomed in, you'd probably be able to see it here. Right? So we need an assignment scores. Here's a list. We'll go get the score. We can append it to our assignment scores. Append the score. And then when we're done, we want to append the assignment scores. Right? So based on how many assignments there were, if it's 0, there's none. We don't have any yet. That's okay. We'll go through and do that. Right? We go add the name, add that assignment scores. To enter a student to edit, let's go get their index. We'll go find it here. Now, scores of index will give us all of their scores. It'll be a little bit ugly, but we can probably work with that. So then we'll probably want to loop through and get out that assignment scores again. Let's see. So we don't want just a new score. We want enter the score for assignment number. So we need assignment scores equals a new list. Here's your current score. And then now we're not appending now. We're going to say, hey, at the index, go assign that list here. Just go update the value. Right? Whatever was there, go put this new one in for that student. We'll be able to do that for the student. To print them all out, sure, again, it's not perfect here, but we'll see what that looks like in a minute. Now we're not going to be able to sum scores right away. This will probably crash on us too. Yeah, I don't think it'll sum right away, but that's okay. And then 4 was going to be add assignment. So this was 5, right, for save and close. And now we needed to change how we're writing this here, right? So for every index, we go and write this. Then we need to go and write the number of assignments, right? Because we wanted to read the number of assignments so I know how many lines to write or how many lines to read. So then I'll take my gradebook and I'm going to write the length of scores at the index. Right? And then make that a formatted string so that I can have my new line character. So if I had 7 assignments, the length of my scores, the inner, right, that row is going to be 7. We'll write the number 7 here, new line character, ending parenthesis. Then I need to go write all those individual scores, right? So then for scores at index, scores at the index. It's our little enhanced for loop here, right? Loop through each one at a time with the little auto loop, or like we did in C++. Now I can take my gradebook and I can write just that score. We'll write as a formatted string so I can get my new lines in here. We'll write the score. And then a new line. So hey, I'm going to have 7 and then I'm going to write 7 numbers, right? Then I'll go to the next index to do the next name, go to the next row in that the scores 2-dimensional array, 2-dimensional list, and go through and write it all. I think that'll work. All right, so we just need to redo 4. So elif choice is 4. 4. This is add an assignment then. So adding a new assignment, we need to get the score for every student that exists. Right? I don't know. So maybe we'll take our number of assignments plus 1. Hey, we've added an assignment here. And then for every student, do we need to go and get their score out? And go and ask? We could, right? So for index in range, length of names, we can get their score. Is a float of an input of enter the score for the new assignment 4. And then we want their names at the index to get their name out. So that should be a formatted string. It's getting a little long, but that's probably okay. Then I have the index, so I can take my scores at the index. That one is another list. From there, we can append the score. Right? So scores at index 0 is the list of scores for student 0. Scores at index 1 is the list of scores for student 1. Right, go and append that score. Should be pretty quick to add that assignment, so we'll go and get the score for every student, right? Because I added the new assignment here. Right, I think that should work. So 3 should print it out. Again, I think this will probably break, but we can try that again in a little bit and see. Oops, when I hit run, it ran the main file. See how it says main here? This is the main PY file. If I want to run gradebook, I can just go right click and say run gradebook. It's usually the fastest way. And now it says, hey, this is gradebook when you hit run. Because this was like V2. So CIS 298. Let's add a space in here. So there shouldn't be anything in the gradebook right now because it was empty. So let's go add a student. And the student's name is Eric. There were no assignments, so it didn't ask me for any assignment information here. Let's go add another student. We'll add Jeb. Again, there's still 0 assignments here. We didn't have any yet, so it didn't ask me for anything. Let's go add an assignment. So enter the score for Eric. Right, I got 100 on the first one. Jeb got 90 on that one here. Great. And then how about we display the entire gradebook? Oh, it crashes here. You can't sum a list. All right, so that one crashed us. Oh, we didn't save the file. Shoot, I wanted to save the file. I knew that was going to crash, my bad. So average score doesn't really work for that one here, but there's, notice name and score prints out. It just gives us that list here for all of them. So we'll just wait on average for now. That way it shouldn't crash on us. We'll try that one more time. So CIS 298, we'll add Eric, we'll add Jeb, and we'll add an assignment here. Okay, so 190. Let's go add one more assignment here. So let's do 95 and 85. So when I display the whole gradebook, I get, here's Eric and his scores. Here's Jeb and his scores. Let's go save and quit. So we should have CIS 298. So we have Eric and 2 because we have 2 assignments. Here's the score for 2 assignments. Here's Jeb, there's 2 assignments. Here's that. Now, this might be silly to save the same number for every single person. Right? We could write this somewhere else just one time and know, okay, that's the value for every single person. Right? Again, we can change it, right? However we want to read it is how we need to write it, or however I want to write it is how I need to read it. We got lots of options for going about doing that. But let's see if it loads here. Right? So we want to run gradebook, CIS space 298. All right, it didn't crash on me, so that's probably good. So if we display the whole gradebook, didn't do it. Let's see, did it go and open? It should have opened. Last name txt. That's a bummer. Let's see. Okay. I mean, 3 worked before when we were displaying, when I was entering values. Let me go and stop here. Let's put it in debug mode. Right, add a breakpoint here, run it with debug mode, and see what's happening. So name of the class, CIS 298. So we're going to try and open. So we're going to step over. Okay, it opened. We get names, we get scores, we get name. It's nothing. How is name nothing? Isn't it 298.txt?
Did it overwrite the file with nothing?
I don't know. It is empty. Did I not? It had stuff in it before, didn't it? Did I not actually check the file for wrote? I didn't see if it actually wrote the file, did I? No, we had a file.
From the original?
From the original. Okay, let's try it one more time. Let's try it. Well, yeah, so I want both. Like, so version 2 should be this one. So I don't blow away my original file. All right, so we'll add Eric. We'll add Jeb. We'll add an assignment. 190. We'll add an assignment. 95 and 85. Save and quit. All right. So we've got the file here. So now we want to try and read it here. So one more time in debug mode. CIS 298. So we're going to open the file, step through, step, read the line. Okay, so now we got Eric. That's good. So while name has a value, we'll get the next line, should be my number of assignments here. Score starts as blank, and my number of assignments is 2. So then for that assignment, we'll go through and read the next value, read the line. We get a score of 100. Great. Add it to our assignment scores. Next score is 95. Add it to assignment scores. We got that one here. And we're going to append name here to the names list. Append the scores to the scores list. I set my number of assignments here. All right, and then, I never reread name, did I? Then we have to read the next line. Okay, so there's probably something wrong with my loop here. Yeah, okay, so it did crash on me. So this probably broke somewhere in here and then went to this accept block. That's what it was. Because we're catching everything here, now when I go through and say, oh, I didn't get the next name out here, it's going to say, oh, hey, read the next line here, turn it into an integer, and we crash because Jeb is not an integer, right? That's my bad. So we opened up and gave it a blank one here. So that's why it blew the file away. So now we need to go read name here. Does that make sense? Where that bug was? Okay. The debugger is your best friend. That we can step through and see what's happening, which is fantastic. So now it should load 298, display the whole gradebook, and now we get Eric and Jeb back. Oh, I forgot to trim here again, or strip. Name.strip. Okay, stop. Run again, one more time, just to make it prettier. CIS 298 here, display my gradebook. All right, now we get the gradebook back out. It's looking a little bit better here. So if I go add a student, it should ask me for their scores because I know I have 2 assignments, right? So if we go add VV, okay, oh, assignment 2.
Because there's 2 assignments, and you had set the display, you had set the number of assignments.
Oh, yeah, that should be assignment here. There we go. Now I'll get the 0 and the 1. So it should work, it's just telling me the wrong prompt here. So let's see, okay, so maybe if you had like 70 and 65. So I display my whole gradebook. 70 and 65. We save and quit. And my file should have all of us. Look at that. It mostly works. All right. So that's some basics of files. We didn't get to the interesting stuff with files yet. Let's see. So this was just making sure I'm hitting all the things here. So we open files for reading, text lines, reading files, searching through a file. Sure, you can go and look for stuff like that. When we play with strings, it starts with is fun. Picking the file name, right? Make sure we don't crash. Try accept. Open here. Yep, that one works. Exit just ends your program. That one's not super exciting. Writing our files. Debugging. Okay, cool. So that's the gist of it here. So we'll get into doing fun things like CSV files and JSON format later. That's not in here, comma separated values. So in Excel, when you make an Excel file and you put a bunch of stuff in here, so like, I don't know, what do we want to put? Eric, and then maybe I do my scores here, 190, 85, 100 again or something. And then Jeb, 95, 20, I don't know, maybe a 0 on that one, and then 100 on that one. When I go save this, usually it wants to save as an Excel file because that's what it likes to do, right? But let me go put that like on my desktop or something. Where is it here? Desktop. You can change the type here to CSV. It's a comma delimited file, comma separated file. Test.csv. And CSV files are just text files, so you can open them up with a text editor or like Notepad, right? Works out really nice. And you get the values separated by commas. It's a very common format for dealing with files and table data, like Excel works with. So anything in Excel you can save as a CSV file.
It actually looks nice too. In C++, you try to do a file like that, it'll give you like the @ symbol and like.
Yeah, you can end up with lots of weird stuff. So this is a very common way of dealing with data. So we'll look at reading and writing CSV files. That's very common when we want to pull data down and do some manipulations with it. That's one way of getting some data out. You can actually open Excel directly, but it uses some other libraries and some other fun stuff. We can look at that later. And this is pretty common for storing internal, just local data sort of things here. Yeah.
So for data analysis, like this is the main, the most common thing that we use.
No. You'll probably just talk to a database or a web service. But if you're doing something local and you've got a copy of the data, yes, here. Right? These files get really large. If you've got a billion pieces of information, that's going to be a really large file, right? Everything nowadays is stored in a database somewhere. So you'll probably just connect to the database, get the information from the database, but it's the same kind of idea, and then we can work with it, manipulate it, play with it locally. Yeah?
And do we have like a CG and CP equivalent here?
You got to help me out. I don't know what those letters mean.
They're in C++. Like CP and CT, one's for reading, one's for writing.
So we just did the reading and writing this way. So you would open.
Now you're like, you seek it from a specific.
Oh,
location
seek,
of the
seek.
file.
So there are ways to go find particular pieces, like location of a file. I don't like doing that because it's a big pain in the butt. Right. For our small files, it's just easier to just write the whole thing out.
Because they had us do that in 200.
Yeah, that's a big pain. I don't like doing it. If you want to, you can go look it up. But yeah, we don't need to go and try and edit files, like change data in the middle of them. That's a lower level that we want to do dealing with text files right now. So, all right, awesome. So we'll meet up on Thursday then. You guys stay warm. Thanks so much.